Okay, now we're recording. So I wanted to put together a workshop to introduce sales engineers to the basic foundational knowledge around AppSec and how web communication works, as well as like API stuff. Because I know as we get more in depth with testing AppSpider, and especially people start testing Swagger, people run into problems, and it's hard to troubleshoot. So this is going to introduce some of those troubleshooting skills. So we're going to be talking about that communication, how do APIs work. I'm going to be showing you some tools and some troubleshooting skills around this. And we're just going to basically walk through the basic foundational knowledge behind AppSec. We're not going to really get into AppSec all that much, and we're not going to be talking about HTTPS, but we're just going to be talking about the HTTP protocol and APIs. So let's start with basic web communication. So this is a traditional on-prem architecture. HTTP is a layer 7 communication. You guys are already familiar with, Chrome and mobile apps, and they communicate with services out on the internet or on-prem through HTTP, which is over TCP. So the web server is going to be actually handling that transmission. It doesn't understand at all what's going on. It just transfers data between Java and the endpoint. So it speaks HTTP, but that's about it in terms of handling requests. It doesn't understand the HTML. It doesn't understand anything that's going on. It just transmits it. It's the middleman. The app server is really where everything's going on. This is usually Java code, Ruby, Python, whatever. This is going to be the business logic that generates the web page behind the scenes, determines whether or not you have rights, whose order belongs to who, and renders all of that information, and then hands off the finished product to the web server, Tomcat in this instance, and then Tomcat actually takes care of delivering it to the endpoint. Then on the back end is the database. That's just storage of the data and helping it relate. There are other models. This is the older traditional one. There are other models with microservices where this can be broken out into many different services. There could be, you could turn off the web server and everything could continue to run in the background as cron jobs. You wouldn't have web access to it, but scheduled scans would still kick off and everything like that if this were an IBM server. You could break up things into many different web servers that talk to each other and communicate. So that would be like a microservices model. There's also serverless services like Amazon Web Services Lambda, which are kind of like an event-based trigger thing, but we're not going to be talking about that stuff too. But this is the very traditional thing that you'll see out there. So I want to show you guys what that web traffic actually looks like. So you can actually pull up a terminal and type in telnet. You can open up a raw connection to Google itself and say telnet to www.google.com on TCP port 80. So telnet is a layer 4 raw communication socket. So it just opens up a real basic connection on layer 4. Telnet has no idea what any of these protocols mean. It's just a layer 4 tool of opening up a TCP socket, and then you guys can basically chat back and forth and send text to each other or binary data. So in this case, all I did was I telnetted to this server on port 80, which is where that web server is going to be listening. And I typed in get the home page, and I want to speak this protocol on this host. And I hit enter twice, and then you'll see Google respond. That's all it is. That's all like HTTP really is on a fundamental level, is basic English text. And then they send a response that has a very particular structure to it. So the first line has the status code, like the 200, which means everything's fine. Then it's going to be all of the headers. We'll be going more into depth into this in a minute. But it's going to be all of the headers that, here's your cookie, here's some security features that I have, authentication stuff. And then down here is just the HTML. This is the message body. So when you go and you fetch the Google homepage, it actually transmits that HTML down here in the message body. This is the foundation of AppSec. We'll talk more about that later. Any questions so far?
So you're probably going to get to this, but in the response body, there's no formatting, right? Which I wouldn't have expected here. But what's the relationship between the formatting you'll see in a regular editor and like just this stream of stuff you see here? Which one is inserted? Which one has the stuff inserted?
The stuff inserted? What do you mean, like
character return line feeds and stuff like that?
Oh, okay. So the line feeds are what delimit things. So your request ends with 2 returns in this case, which means I'm done talking to you. Then the server says, okay, I'm going to begin processing all that stuff that came in. So the first line is always the status code. Then the formatting always goes.
Tim, I get that. I'm talking about the response message body.
Oh,
so
down
the
here.
headers all have a proper character return line feed, and they look somewhat formatted. But the body is all just a stream, and I don't see like backslashes or anything that would delimit escaping a line feed.
Oh yeah, there's not necessarily line feeds or anything down here in the message body. This is just like the HTML coming in. HTML doesn't necessarily have to have line feeds in it.
Okay, got it.
That answers your question. Sorry.
It always breaks with slash. I don't know what that character is called, but in HTML, that's how you end like a line. But yeah, it's usually a blob, but there's tools that you can view it that it's a little bit neater.
Yeah.
Okay. So it's the fact that the tool layers it over. Okay, got it.
Yeah. So let me see. Obviously, this is a very inefficient way of doing things when you're manually testing stuff, so we're going to get to more efficient ways. But this is basically what recorded traffic files are the recordings of all the individual characters that were sent back and forth. So let's tear into these request components a bit more, because this is the basics for AppSec. So that top line previously was like a get, and then which particular page or URL you want to get, and then what protocol. Then you can specify additional headers in here. This is where you oftentimes provide authentication information about who am I. Here's a token, here's an API key, or something like that. We'll get into authentication more later. Down at the bottom, though, parameters are exclusively in the URL itself. So in this case, we're going to Reddit, and we're going to search Reddit for cats. I want to find anything that has the word cats in it, and I want to sort by the top of all time, and I want it to come, or I want it to sort by top and from all time. So you can specify things in the URL. Things in the URL, these are things that you can bookmark. If you guys ever send a link to somebody for like an item, you're like, hey, I'm going to buy this, and you copy and paste the URL to somebody, and then they go to that page, and then it doesn't work. It doesn't take them to the item that you were on or the specific version of it. Has that ever happened to you guys?
Oh, sure.
Yeah, that's because not all of the information was in the URL itself about the request. Some of it was down here in the message body. And when you just copy the URL, it doesn't transmit the message body as well. So these are things that you can bookmark or send links and share with people. Things down in the message body are typically more secretive information that they don't want saved in logs, because URLs are going to be saved in logs. Unless you're doing full packet capture, you're not going to catch all of this stuff that's in the message body. So sensitive things like passwords and credit card numbers are going to go inside the body. But you can specify additional variables down in the message body. So get posts are when you request information from the server, when you like fetch this web page for me, and you may specify like this down here is a get post, but you may post data too. And post data says, I'm going to submit stuff down here in the body to you. I'm going to authenticate to the web page, and we'll show an example of authenticating to WebScan test in a little bit. Any other questions so far? Okay, so AppSec is all about futzing with all of this stuff. These transmissions that you're sending from your endpoint is all about injecting nasty little things inside of here that trick the server into doing something that it's not supposed to do. So a lot of times you're attacking down here in the message body, and you're sending JavaScript inside of here or SQL, and you're trying to trick the server into executing that code or handing it off to some other innocent bystander to execute that code. That's basically what AppSec is futzing around with this stuff to try to get something nasty to happen. So you can use Chrome to view a lot of this information. It makes it really easy for debugging. So what you do, and I'll give a demo of this, is you basically right-click on the page, and then you open up Inspect. You can see all of the headers in here. You can see message bodies. It'll do fancy formatting like you were requesting, or you can view the raw traffic too. You can also steal cookies. I'll give a demo of that in a bit. When you need to do like attack replay, or you need to copy and paste it somewhere else, you can steal cookies doing this as well. When you're troubleshooting problems with our tools, sometimes you run into problems where AppSpider won't crawl a certain page, you're not getting a proper sitemap, or you're having trouble authenticating. What you need is you need to enable traffic logging in order to troubleshoot these things. By default, AppSpider doesn't record everything that happens. It's a huge amount of traffic and makes huge logs. So you have to go in and enable this and then have them run a rescan. And then you can start digging through the logs and you can look directly at all the message bodies to start looking for, okay, what could be the cause of the problem in here? Why isn't the universal translator recognizing that this is Angular? Or how are they authenticating behind the scenes? And how do I kind of jerry-rig this to make it work? Just make sure you have lots of disk space available when you do this. So when you download, when your browser downloads that HTML, it parses the message body, and then it starts to render it in memory. So Chrome downloads that HTML from the message body, and it starts to parse it. And it loads it into memory on your local machine, and then it starts to parse it and build basically an XML tree of the document that's called the document object model, the DOM. And you may have heard like How and stuff talk about this a lot. So the DOM is the in-memory copy of the web page that can be changed. The DOM is dynamic. So Dast engines, 10 years ago, 20 years ago, HTML was static. Once you loaded a web page, that was it. If you clicked on anything on the web page, it took you to a whole new URL up in the top of the browser, and you got a whole new page with all new stuff. And that's the way basically the Insight VM's crawling engine works. It's not very smart. It doesn't really run the page. There may be some JavaScript behind the scenes that's actually rendering different parts of the page and streaming them down. That's called a single page application. And I'll show you this in a demo in a minute. But when you hover over certain parts of the site, it may stream and pull another part of the page and then modify the DOM. Because it may be faster to load a web page and just kind of load the main thing and then give you the little pieces as you need them, instead of waiting 2 minutes for the whole entire thing to download, even though you don't need to access 90% of it. So Dast engines have to emulate that JavaScript engine and pretend to be a human. So they have to hover over things, they have to click on things that kind of pop up inside there without changing the URL, and in order to find all the different pages, because you can't attack what you can't crawl. So Dast engines, and that's where the universal translator comes in, is really good at emulating all of this JavaScript stuff and finding every nook and cranny of the website. Like I said, DOMs are modeled basically after XML structure, like HTML, and they are referenced by what's called an XPath. So it looks a lot like relative file paths or absolute file paths in Linux. It's just like / notation to denote where in the DOM you are, a lot like a folder structure in Windows or Mac. And you can use the inspect tool in Chrome to look at the DOM and play with it and even live edit things. Any questions?
Hey, Tim, it's Andrew. I got a quick question just on your slide before about traffic logging. Where would, after you've enabled that and you run the scan, where would the log actually reside?
Sure. So with AppSpider Pro, it's going to be like in the My Documents folder, there's an AppSpider folder, and then inside of that, there's like a scans folder, and then the names of your different apps are going to be in there. So it'd be like the web scan test folder, and then there'll be like a logs folder, and then you'll see like another folder underneath that that's like the traffic log. The operational log is like the main one that you usually look at, but there'll be an additional folder, I think, with another file in it that's like the traffic logs. It should be right alongside the rest of the logs, basically.
Okay, cool. And then for IIS, how would that be saved?
Inside AppSec, you have to enable this, rerun another scan so it saves the information, and then when you click to download the logs, I think it comes in as a single zip file. It's all zipped up in there.
Awesome, thanks.
Sure. So, like I said, JavaScript's really important to being able to crawl the whole website. So you got to be able to emulate and understand all these JavaScript commands so that you can pretend to be a human and hover over everything and click on everything. So currently we support those listed frameworks. There are tools that you can use if you're doing like a POC and someone says like, oh, it's like a publicly accessible site, or maybe the production version of their website. You can install a Chrome extension called Wappalizer, and you can just click on it, and I've got a screenshot of it there, and you can see what tools are running or what technologies this site is based off of, and you can get a rough idea of like, oh, well, yeah, there's knockout version this, or oh, it's you know, it's an unsupported version of React or Angular. It's too new. We don't support that. Sorry, we're not going to be able to scan it. Instead of like going through the POC and wondering why doesn't it work? Why doesn't it work? When you can just have Wappalizer tell you like, oh yeah, there's something in here that's not supported. I get asked pretty frequently about Node.js. JavaScript is just a general language, right? It's just a syntax. JavaScript can run on the endpoint, which is what it's most famously known for, running in your browser to do things like animate stuff. But JavaScript can also run out on the server. So Node.js is server-side JavaScript. You do not need to support Node.js because we never see it. It's all behind the scenes. We are only, remember, communicating over HTTP. AppSpider and Dask engines do not care what language or code is executing on the back end over on the web server. It only matters what they hand us. So when someone says, do you support Node.js? You say, that's a server side, it doesn't matter. Any questions about that? So there are some challenges associated with the way things are today. There are JavaScript frameworks like Vue, Ember, and Backbone that we don't support yet. There are other gray areas like WordPress. When they say, does AppSpider find WordPress vulns? Well, it can find CWEs, which are like, you know, OWASP Top 10, SQL injection, that sort of stuff. But oftentimes people are looking for vulnerable plugins that they've installed, known versions, almost more like CVEs. That's not something we look for. We don't look for CVEs with AppSpider. That's more Nexpose and Insight VM territory. But even then, neither of our tools really do that. There's point solutions out there for that. I have run into a problem recently on a POC where they were running Angular and they were running React, and they were using Angular in order to render the React, and nesting these different JavaScript frameworks caused a problem with the universal translator, even though it shouldn't have. They were in the midst of transitioning from an old version of Angular to a new version of React. So half of their site was written in each of these two different languages. But the weirder part was they were using one to render the other and handle routing. And so the universal translator engine got all confused.
Did they say why they were doing that? They just wanted to move away from Angular?
Yeah, they were just migrating away from, I think they were using AngularJS, which is the very first version of Angular. And they were migrating to React. I don't know why, but instead of releasing the site when it was completely done and all in React, they had a hybrid version of the site that was up. And we had a pretty difficult time crawling it. So we had to provide a bunch of additional seed URLs to get it to certain pages where it couldn't find.
Yeah. React's easier to code in, but that's, yeah.
So it's time for the first demo. So we're going to walk through basically this Chrome inspect mode. So you guys should still be able to see my screen right now.
Yep.
I'm going to log out here. So what I've done, I'm going to close inspect mode. So I right click and then I click inspect, and it's going to pop up this window again. And what I'm going to do is, I'm just going to like go to the home page first, and you can see it load things. And over here, this is the DOM. And you can start expanding things, and you can hover over things, and it will show you where in the DOM that is located. That's the Elements tab. If you need to reference things. There's other things you can do in here as well. So what I'm going to do also is I'm going to go over to the application tab. Application tab allows you to steal cookies. So I'll go into this more in a second when I demo it. But also, oh, the network tab. This is where, so this, you're going to see a bunch of different gets in here. So when I clicked on load the page, it actually went out, it fetched this first, which is the main web page. And then since it's a browser, it automatically goes and downloads any dependencies. So it found this GIF file, some spreadsheets, and this is actually one of my Chrome extensions, where it's going to go and fetch everything else. So I can click on this particular page, and then I can see what the request was. And here it's doing the fancy formatting of it. I can click view source and it will show me the original transmissions. This is just like we saw in Telnet, but with a lot more going on because Chrome is identifying itself and sharing a lot more information about what do I support on my end. And then in the response headers, you can see what came back from them and you can see the body as well. So let's see, so that's inspecting the DOM, the traffic, and the body. So let's log in. So I'm going to go to the login page, and I'm actually going to log in. So now the actual login occurred here at the top. It was login.php, and you can see what I sent to them. So here's the post data. We were talking about posts. Remember, a post is I'm transmitting data to you up to the server. So you can see that basically I said I want to post to the login page, and then there's a bunch of headers that aren't really that important. But down here in plain text, you can see the username and the password were transmitted. So login equals admin, password is equal to admin. And so that's what I transmitted. And remember, this is the basis of AppSec. So if I want to start injecting, I can start putting screwy information in place of admin and start screwing and fuzzing parameters in here. So when they talk about fuzzing, it just means I'm going to try a million different combinations of screwy different things to try to make the server do something with these different parameters. The parameters in this case would be login, password, and submit login. Any questions about this? Okay, let's steal a cookie, because let's say there's a case where I'm in POC and I need to do a replay attack on a particular vuln. So pick on web scan test because that's where I am. Pick a particular vuln. Now let's say a particular vuln is behind an authentication page. I'm just going to pick on this one. Now this one isn't actually behind an authentication page, but there's some parts of the site that you can't get to unless you're authenticated, right? So I'm going to do a replay attack. Ah, geez. That broke everything. One second. All right, can you guys see my screen again?
Yep.
Okay. Was that a yes?
Yes.
Okay, cool. So I'm going to go back over to application, or I can go to the header itself. I can say, okay, here's the response headers, and then I can go to application, I can go to cookies, and I can see that the cookies that are currently set are these two. Test session ID, well, that's actually what I'm looking for in this case. And I go to the vulnerability validator, and then over here, I can edit my request before I send it off. And I can go to the cookies page, and I can set test ID is equal to this. And I can save changes and replay the attack. Now I don't have to worry about authentication. I've already taken care of it because I've stolen a valid cookie after getting like a real logon. And these cookies may expire in minutes or hours or days. Any other questions about what I've shown you so far? I do want to show you like another one.
Hey Tim, sorry, I may have missed it in the beginning, but yeah, that window there with the you're inspecting, is that a plugin or is that just part of Chrome?
It's part of Chrome for everybody.
Oh, okay, yeah.
Yeah. So what I'm going to do, and you can watch. So I'm going to click submit feedback. Now the URL at the top didn't change, but a window popped in the page, and you can see a bunch of other things came up in here. So I can go in here and view all these different smaller requests that JavaScript is doing in the background to change my DOM. And then I can go back over to the Elements tab, and I can see that my DOM has changed because I'm streaming additional parts of the site down into my DOM. So Newegg is an example of a single page application, because when I click on this, whoops, I clicked on it twice. When you click on certain things or hover over them, the URL at the top is not changing. So that's the first demo. Make sure I'm still recording. So I showed you guys some of like the HTML that came in. When you're parsing through that, the way the Universal Translator Engine works is it digs through all of those message bodies, and it looks for certain keywords that are unique to different JavaScript frameworks. So the way that it knows which plugin to switch to is, let's say it's looking for React.js. What it's going to look for is create React root index. If it sees this anywhere in the HTML, it knows, aha, I've got some React.js version 2 in here. And then the Universal Translator Engine can say, I need to call my React version 2 translator up. And I now have properly identified that JavaScript framework and can interact with it because I've got a little piece of my engine that just knows how to handle React version 2, and now I can play with it and stream the rest of the DOM down and then recursively get the whole page. The problem can be what happens if what happens if the developers didn't use that particular function name. I ran into a POC recently where they were using AngularJS, and ng controller was what we had things set to look for, but they didn't have ng controller anywhere in their code. They weren't using it. What they were using was ng-app instead. So we had to change the Universal Translator Engine to say, look for ng-app instead on this particular app. And then bang, we knew that, okay, it's definitely finding the right framework now. So if you look in the operation log and you grep for framework, blah, 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 detected for external script or web frameworks detected, then you can watch as the Universal Translator Engine's going. It'll say, aha, I found React.js version 2 here. I found Knockout version 1 over here. And you can see it recognize things. So if you start grepping through there and you see, oh, it didn't recognize that Angular is here at all on a particular page, you might need to go back, look through that HTML that they sent and say, what's something in here that would tell it that there is some Angular in here? And so you have to go through and find another function name to do something like that. Any questions about that? I know that's a lot, but this is a great thing to grep for. And the commands and examples for this, there's a ton of example slides after the end of this presentation that have like an excruciating amount of detail that I would recommend looking through, that have a lot more examples of me actually doing this in the command line to show what it actually looks like. So let's talk about APIs. So how does a program like Pokemon Go work if there's no web browser? Well, you need to be able to transmit the data maybe just on a more raw level. Normal web pages, serve up things really fancy. So if you were to order a slice of bacon, they would dress it all up and make it look fancy and take care of all the presentation for you. And all you have to do is basically render that in Chrome. APIs, when you say, I want a piece of bacon, they just give you just the bacon. It's the application's responsibility that's receiving that to take care of all the processing and decorating it and making it look pretty. So when you file a request with an API, you're cutting out kind of all of the decorative stuff and all of the fancy HTML, and you're jumping straight to just this tiny little piece of data that I want you to know or I want to get from you. So application programming interfaces are just a way for computers to talk to other computers without a human involved in a pre-agreed upon protocol. So it's HTTP without any of the HTML. There's no user interface, there's no web page, it's just kind of the meat without the burger. So in this case, RESTful APIs are JSON. You can see one over here on the right. You can say, get this page, and that's the whole request. And then the body of the response, including, instead of HTML, it just sends just information about the list of articles mentioning who the author was. And so it's now the application on the endpoint's responsibility to decorate this, pretty it up, figure out how to display it to the user or process it. You'll notice that since there's no HTML here, there's no links to anything else. So you can't crawl it. Crawling is the process of digging through HTML, looking for links, and then recursively continuing until you can't find any more pages. So you can't crawl an API because the individual APIs don't really refer usually to other pages. So you need a different way to get that information. Any questions about APIs so far? We've got several more slides about this stuff.
No, this is great stuff too.
Oh, good. Thanks, George.
So does the tool support both REST and SOAP stuff?
Yeah, we support both REST and SOAP. So REST is JSON, SOAP is XML, is the older format, just for everyone else's knowledge.
Is there a real reason or benefit, like you go from one to the other, or is it just preference?
JSON's the more supported one. Everyone who's writing tools and libraries and stuff these days are doing it in JSON.
Yeah, SOAP came out like 10, 15 years ago, didn't it, Tim? It's actually longer than that.
It was a while ago. The original Insight VM API is written in SOAP. So if you took the class for Nexpose back in the day and you took Nexpose 201, you were writing XML in the requests and stuff.
I can remember when SOAP was new.
But there's no real benefit. It's not like one you go from one to the other. It just kind of.
Yeah, no. Correct me if I'm wrong, Tim. You know a lot more about this than I do, but I think SOAP was the original one, and going RESTful is kind of the more modern way to do it.
Exactly. Yeah. SOAP's old. JSON or REST is new.
Gotcha.
And then typically with like most SOAP APIs, there's a lot more just lines of crap that isn't really necessary versus REST is a little more simplified.
So on top of that, is it more efficient? Is there more capabilities?
I wouldn't say that there's necessarily more capabilities. I would say it's definitely smaller sizes of transmission, because instead of like this single bracket, it would be like open bracket XML question mark, close bracket, and then like there's just a lot more characters and like I think Justin said, some useless stuff in there.
Yep.
So since there's no, we're talking about authentication. So since there's not like web pages where you can click in a field and say, here's my username, here's my password, you may have to have slightly different ways to authenticate. So you could use authentication like username equals this, password equals that, like you saw with web scan tests, and pass those in the body, preferably not in the parameter. A lot of times APIs don't use usernames and passwords. They do, like with Insight VM, but they usually use API keys. Because if you're talking to an API, you need something that's like more permanent and long-term than necessarily a password. So you'll get an API key. So that's basically functions as a username and a password, and is all that you need for authentication. And then you store that as a header. And then with every single request, you say authorization, :space, token, space, this. So every time you talk to it, you pass that token, and then they know who you are and can authorize your activity. Usually authentication is almost exclusively taken care of through headers once it's established. Security, like more advanced tools, are going to do a lot more stuff with the headers to make sure that there hasn't been a man in the middle, that it hasn't been altered, that you are doing the thing you think you're doing, and stuff like that. So there's a lot of extra headers that you guys saw earlier that prevent like cross-site request forgeries and stuff. So authentication can get a bit more complicated than copying and pasting a cookie sometimes. So here's how to do it inside AppSec. You basically go to custom options, HTTP headers, and when you're configuring an API scan, usually they'll tell you like the header needs to take this format. The customer will specify, and in this case, you know, it might be authorization space, API key space, and then whatever that unique key is. I've also seen it where it's just API key, colon space, and then the key. And devs will usually have pre-approved tokens or keys. So this may not be a number. It may be like QA dev test 1 or something like that. You copy and paste in. All right, so let's talk about Postman. Postman is a free tool that's designed for web API development. It allows you to play around with these requests before you send them. You can manually send them. You can do things in an automated way and run tests. And more importantly, you can import Swagger files, which is going to make things a lot easier. It is not a pen testing tool. It's a dev tool, but you can use it for basic parameter fuzzing if you wanted to do that manually. There's better pen testing tools for that sort of stuff. So let's do a demo. What I'm going to do is I'm going to visit google.com. One second. Okay. So I'm going to go to the Google homepage. I'm not going to really pass anything. I just want to show you that it's the same thing as the Telnet example from earlier. So I'm going to set this as a get request, and I want to go to google.com. I haven't plugged anything else in here. This is just a really basic request. And then you can see all the pretty HTML in here, and you can even see what it looks like. Now, since this isn't a real web browser, it's not going and fetching the images or the style sheets. It looks like 1990s really basic HTML because it's not doing all the formatting because I haven't fetched all those additional things. This is just one response. So you can also see what cookies they handed back to me, and you can see what the headers were that they sent back to me as well. So you can kind of analyze all of this traffic, and then you can download it and process it as well. Okay, so let's talk about basic authentication with APIs. So with Hackathon, Hackathon authenticates with by you pass a username and password the first time, and then it hands you back a token. I know this because I read through the documentation, and there's a PDF file that you can read that I have a link to in the references that explains how Hackathon works. But Hackathon has an API, and basically what it's going to do is you hand a username and password to it, and you have to specify that this is basic auth. I click send. Now it says your token is established, and it handed me a token back. So what I'm going to do now that I want to get the list of orders, you know, that my account has previously made, I'm going to go down to my list of orders. If I click send right now, it'll say you must be authenticated because I didn't pass over the right information. So what I have to do is I have to paste in this token, and then I click send, and now I can authenticate to the server and then get the list of the orders that I've made in the past. Does that make sense?
Yeah.
So instead of passing a username and password with every single request, you pass a username and password once, and then they hand you back a token, and then you just give it that token every single time that you log in, or that you pass that as a header back. So there are easier ways to do that with Postman, especially if you're going to be running a lot of queries. There's some cool automated stuff that you can do in here. So on the first one, I've got the same thing set up. My username and password are plugged in. I'm going to start over and do authentication again. But this time, after it finishes, I'm going to have this code execute on my local machine that's going to store a local environment variable. So I can go up here and I can see from a previous test that, you know, I'm going to delete this, that my token is blank. And so I'm going to click send. It fires off that token, and then this code executes, and then stores that token as an environment variable inside a Postman. Now I can call that on subsequent ones, so I don't have to do the copying and pasting, and instead I'm calling the environment variable from here, and now I can click send, and now I get the same information, and I can go to other functions, and I can click send, and I can pull information like get product 14 or whatever. And this JSON is coming back, and then my tool would then have to figure out how to render it. This would be more likely for a mobile app, would make this call, and then it would already know how to format this in a pretty way for the user. You can also use environment variables in Postman to avoid hard coding things. So you could have like a project and be pointing at one Insight VM server, and then without having to copy and paste the IP address 50 times, you can just change the environment variable that references it once. So you can use environment variables to save you a lot of time if you're going to be doing repetitive stuff. Any questions about that? Okay, I'm going to go back to the presentation. Okay, so Swagger files. Like I mentioned, when you're using API, there's no HTML, so there's no links that refer to other pages. So if you're going to attack an API, you need a list ahead of time of all the places, because you're not going to be doing any crawling. You need a total list of all of the different what are called API endpoints that you're going to be communicating with. This is the same sort of thing when you're scoping a pen test that's going to be used to reference how big is the pen test, how much time does it take. You can count that by the number of API endpoints, which is roughly an estimate of how many different things am I going to try to hack, how many points of entry are there. Swagger files and Swagger in general, you can think of as a blueprint for a house. It's up to you to choose what language. You know, you can use whatever building materials you want. You can make the house out of steel or wood or diamond or aluminum or whatever. It doesn't matter, but you can't step outside the parameters of the blueprint. So in this case, the Swagger file is a guide for communicating with a server, but you can use this to write in any programming language you want. You could implement it in Python or Ruby or Java. It doesn't matter, because all that matters is as long as your text that you're sending out to the web server looks like those API calls that we were seeing, it doesn't matter behind the scenes what language it was written in. So Swagger files allow you to quickly import and build language support for particular APIs. Swagger files document everything about the API. They have a list of all the parameters, all of the endpoints, all the different ways you can authenticate, what different responses to expect. And you can take these Swagger files and you can convert them into like Python modules so that you don't even have to know how the API works at all. You just have like a Python module that says like authenticate, get product, things like that. So now I want to show you how to use Postman to do that. Okay, so you can do import and then choose files, and then you can pull in a JSON file. Now I'm not going to do it because I've already done it, but it would pull it in this case for the Insight VM API, it pulled in 319 different possible requests. So it's already imported everything in a nice, friendly, easy to read format. So I can like look at get asset groups and see all the different parameters it takes, see what the headers look like. It's already taken care of everything for me. All I really have to do is plug in a URL and a username and password, and I can start communicating with this server. So that was how to communicate it. Oh, here's what they look like, by the way. So well, you guys have already seen the Swagger files, but like I don't have the Insight VM one up anymore. Okay, so let's actually authenticate to a real Insight VM server. So up here, I've plugged in a real IP address. So I'm going over 3780. And then here's the URL I'm going to hit. I'm going to use a get method. I've disabled all these parameters because I don't really care. Authenticating, I'm plugging in a username and password. The documentation tells me, and so does the JSON file, that basic auth is the way that Insight VM communicates. So I click send, and then it goes out and it downloads the list of of all the different asset groups. So I can click send. Whoops. And it returns everything in JSON format to me. And then my Ruby code or whatever could parse this and then start doing information if I got a list of engines or something like that. So that's how to authenticate. That's how to import a Swagger file and communicate with an Insight VM server using the API. Any other questions on that one?
No.
Okay. So you can convert Swagger files into Python modules in the command line. You'll need to go get a tool, but I'll show you how to do that right here. This tool is called Swagger CodeGen, and I'll show you how to do it in Swagger Inspector too. There are GUI stuff too. What?
So Swagger CodeGen from the Linux command line is just an apt-get install, right?
I forget where I got it from. I installed a whole lot of different tools. It might have been through Brew. It might have been, I'm on OS X, so I don't use apt-get, but it would either be like pip, easy install, Brew, or maybe apt-get.
Okay, so it's not part of this distribution. It's okay. Okay, got it.
Yeah, yeah. It's not part of like a standard distribution. It's a dev tool that you have to go get.
Got it.
Okay. So I'm going to do that now. And I'm going to explain the command that I'm pasting in.
Got to change the name of your MacBook now, Tim. You're not in Austin anymore.
That's true. That's very true. So what this is Swagger CodeGen, and I want to generate, and my input file doesn't have to be on my local system. This is a link to the Swagger file for Insight VM out there on the internet. I want to generate a module in Python, and I can specify a variety of different languages here. And then I want the output to go to this directory, Insight VM API Python client. So with one command, boom, it's like compiling everything and taking care of it for me. It only takes a few seconds. Then I can do ls Insight VM. And now there's subdirectories in there, but I've got a Python module that's made just for me that will communicate with the Insight VM API. I don't have to know how the API works at all. I just need this Python module, which is pretty heavily documented and explains itself in the code. You can also use Swagger, Swagger IO.
Tim, if you go back there on that last slide for a second.
Yeah. One sec.
No, the one with the code on it. The one that,
Oh, the command line?
No, the stuff we're just looking. Here we go. Are there any payloads that you can identify in there, or is this just a
Payloads?
I mean, because that's pretty much the way we try to test APIs for how weak or strong they are, right? We parse the web docs and the service docs and inject payloads. Isn't that right?
Yeah. Oh, sorry. I guess I didn't communicate this clearly. So this is not something that you would attack directly. What this is doing is taking that JSON file and then converting it into source code in Python or whatever language I specify that I can then use to write additional code to base my code off of it. So if I'm comfortable with Python and I want to interact with the Insight VM API, I would import this thing and now I have a Python module that's just like pre-made, ready to go, and I can use it to write code that now interacts with an Insight VM server. This isn't for like attacking or payloads or anything.
Okay, thanks.
Sure. So you can also use online tools like Swagger Editor. Now, careful with these. These are great and easy to use compared to command line, but they are online. And so if I take a customer's file and I say import, the Hackathon Swagger file, it may be uploading this file in the background to this server for analysis. And so you may be handing sensitive information up to SmartBear in this case. So I can use this for parsing and looking at stuff in a pretty way, but I can also generate a Python client this way as well. And this is an easy way to hand off to customers because then it kind of transfers the risk to them. But you can generate clients this way too. I've had customers do this as well. Okay, we're getting near the end. Okay, so I installed Swagger CodeGen with Brew on OS X. It was in Brew. Troubleshooting issues. The number one thing to ask them that I found is, hey, this particular file that you sent me, have you actually tested it? Have you actually used this thing before? Because a lot of times they'll generate them and say like, oh yeah, it works, but they've never actually tested it.
I've never run into that problem, Tim.
No? Or like they'll generate one for prod and then they'll hand that to you and expect you to test dev with it. And now that file is trying to point at dev or prod servers, but your settings in AppSpider are pointed at dev, and it can't find any URLs to attack because there's no intersection between the two of them. So start opening that file and just look at the host and make sure, like, is this really pointed at the server I'm saying it's pointed at? Because the host name is mentioned in there. Make sure it says Swagger in there. It should start basically with the word Swagger. They may hand you a RAML file, which I'll talk about in a minute. If you still don't know what's wrong with it, hand it to some JSON validators that I'll demo in a minute. Make sure that there's not like an extra quote somewhere or a missing bracket. Once it passes that test, pass it through some Swagger validators. Make sure that the Swagger itself is valid. There's online ones in a web browser, and there's command line ones that, like I've already shown. The most common issue that I run into is people don't have the host, the base path, or the schemes field. These are three important fields that actually define how, what's the host, is it HTTP or is it HTTPS, and what's the kind of the base start of the URL. And again, beware of submitting this to online sites. If you see base URI in there anywhere, it was converted from a RAML file. So not everyone uses Swagger. A lot of people, especially that have MuleSoft tools, use RAML instead. And it's basically the same thing, honestly. So you guys are all familiar with CSV. YAML is like CSV. It's just a general file format of a way to organize data. And it basically involves white space and tabs and the dash and the /. And so, but we know that their CSV format can be anything out there. It's just a way to represent the data. But, like Qualys exports to CSV are a very particular type of CSV. And that's kind of what RAML is to YAML. So YAML is just a generic way of representing data in a file, and RAML is a way to document an API using YAML. People use the terms interchangeably, but really it's RAML files that you'll be getting. The tricky part about RAML files is Swagger files come as one file. So if you've got the one file, you've got everything. With RAML files, that's not necessarily true. They can reference other files, and so it could be composed of 4 or 5 or 6 files, and if they only send you one, you don't have the whole thing. And sometimes converters don't dig through the other files and they can't understand those references, and it will break things. Because they'll hand you a Swagger file that they converted, but the conversion is bad. The way to know this is if you start seeing like @ref or base URI in there, you know it's been converted behind the scenes, and you're probably going to have to do a lot more hand conversions and dereferencing yourself. Make sure that they're converting things correctly. And the last demo, more command line stuff. So let's talk about validating and troubleshooting JSON issues. Okay, so the first thing I'm going to do is I want to validate some JSON. So I'm going to use JSON lint. And I have a particular file here that I've intentionally screwed up. So I'm going to use JSON lint, which is a command line JSON validator, to dig through this Swagger file that they gave me and said, and oh, it's perfect. And so it parses it and it says, hey, you know what? On line 8, you've got 2 quotes in a row. You shouldn't have that. So I would go in and delete that 1 quote and then run it again to see if that fixes it. So that's validating the general JSON, the general format of the file. It's not knowledgeable about the API stuff. It's just checking the JSON. I can use a different utility to check the Swagger itself. So I can use Swagger, CLI, validate, jukebox API, converted.
Hey, Tim.
Yeah.
Notice you didn't mention the AppSec toolkit. Do we use that as part of our tool set of, our arsenal of tools?
Yeah, I do for importing the Swagger API once it's in the right format. Oftentimes, when I try to pull it into that tool, it'll just say invalid file and doesn't really give me any more hints about what's wrong with it. And so I start having to use validators to dig into that Swagger file and try to figure out where's the syntax problem, where did they screw up the host name or something like that. So
sounds like I would default to the command line then.
That's what I prefer. That's what I'm comfortable with. Oftentimes, like our tool allows you to edit Swagger files and convert them into recorded traffic, but it's not good at analyzing them for problems, I've found.
Cool.
So this tool is, go ahead.
Sorry, yeah, that was my last question. I got to run for my 3 o'clock.
Okay.
Thanks for that.
Yeah.
I'll look at the rest of the recording as well.
Sure. So yeah, we're almost done. We're at the end here. So I've built a file that has valid JSON but invalid Swagger. So I'm going to scan this, and it says, oh, your host is not in the right format. In Swagger, Swagger hosts should not be URLs. So the customer sent me something. I need to get rid of the HTTP and the /API, and those need to go into other variables. The host variable should just be this part only. That's the problem with this file. There's additional references here. I'll send this file around for offline. So there's a lot more links in here, and there's even more than this if you keep going. The key takeaways, attackers modify that HTTP request to perform exploitation. You can play around with Chrome Inspect, Wappleizer, traffic logging and Postman to debug things. If you're having trouble crawling things, you need to enable traffic logging, and you need to start looking through the body responses to see, okay, did it recognize the JavaScript framework in the operations log? If not, what's something I can put in to the regex to make sure it recognizes the right one? RESTful APIs are just a pre-agreed upon HTTP protocol that's gotten rid of the HTML and replaced it with JSON and can be done in any programming language. And lastly, people always misformat the Swagger file, and you'll need to use validators to fix it. I don't know if I've ever gotten a single Swagger file that worked on the first try from people.
I haven't.
I haven't either. Not as many as you have, but not as none.
There's a lot more slides in here that have examples of some of the things that I did and explain them step by step, like how to look through the operation logs and grep for certain things, and examples of the stuff that I did, and a real world like Swagger file correction that I had to do for a customer. So go ahead and parse in here along with like the automation code that I did for Postman. I'm going to go ahead and stop the recording now and then see if there's any questions.